Now, when it comes to determining the dimensions of your given solid, there are some choices that one could use in order to do that very thing. The one that's familiar to all of us, of course, is some type of ruler. We use metric, as most of the world does. And so you can see that this ruler here is broken down into centimeters, but even smaller than that, down to millimeters. So we say that this ruler has a millimeter or zero point 0.1 centimeter precision. And we most certainly could use it in a fairly careful manner to get all of the dimensions that we would want from this particular item. But there is a way to use a device that's even more precise than a ruler. And so when it comes to finding the dimensions, once again, the length, width, and height, we can use what's called a vernier caliper. So when you open your kit, when you come to lab, you'll see a device that looks like this. And it's electronic, so it has a digital display, and it's fairly straightforward to use. There's a screw which is on the top right here, and what we want to do is make sure that he's loosened so that the caliper is free to move, as you see. Now, basic functions, you have three buttons which are on here. There's the on-off, usually come on automatically once you open the jaws, as you see here. There's the zero, and in this case you see that the instrument's not been zeroed. So what we want to do is press the zero button one time, and you should see 0.00. And again, using metric, so the top button, which is here, lets you toggle back and forth between millimeters and inches. We want to make sure that we have millimeters on there. Now, the way in which this instrument can be used is threefold. There are these outer jaws, and these outer jaws will allow you to take a length, width, or height measurement. You can also, on occasion, we'll be making use of these with the hollow cylinders, but these inner jaws are often used if you want to get to, say, an inner diameter or inner inside measurement. And there's even a third, which is called a depth gauge, and this is another way to get, say, the height of a material, for instance. And so we can see then that, say, for instance, we want to get a dimension here. What you want to do very simply is you close the external jaws down, but only using gentle pressure. And in so doing, you'll automatically get a reading down to 1/100 of a millimeter. Notice that's 100 times more precise than a ruler. And so a good school of thought is whenever you're getting a particular dimension, you don't want to just get the dimension on one part of your material, but rather several points to allow for possible variation along that dimension. And in so doing, you can get an average. And you can do likewise for the other dimensions. And so how do you know if you have a recording which is reasonable? Well, if you look here, you see this reading says 23 and some millimeters. So meaning we expect the measurement we just took between 23 and 24. We can double check that with the analog scale that's over here, and you'll notice that that is indeed pretty close to what the analog scale is saying, because you can see 23 tick marks that are being shown there. And so that allows us to accept that this number is correct, since those two match against one another. So that's how you can do that. Now, when it comes to shapes which are like the cylinder that you see here, we can once again get an outer diameter if we like. Right? But in order to get his volume, we're also going to need an inner diameter. So this is where the inner jaws come in. And once again, applying a light kind of pressure, for volume, we can arrive at the density in short order. So that's pretty much all there is to the vernier caliper as far as an introduction to it. And so you'll have lots of practice using this device.